Okay, so we're going to be looking at factoring binomials. Okay, factoring binomials. We're going to start with a quick review on factoring trinomials. Remember, trinomials has 3 terms. Binomials would have 2 terms. So factoring binomials, we did a method called split the middle. We started with target product, target sum. Okay, target product, of course, is the first times the last. So 2 times 2 here is 4. Target sum is that middle number, which is 5. Okay, so my target product is 4, target sum is 5. I'm looking for 2 numbers that multiply to 4 but add to 5. That number would be 4 times 1 multiplies to 4. 4 plus 1 adds to 5. So those become my 2 new numbers. So when I do split the middle, the first term comes down, 2x squared, that's the first term. And then we will split the 5x to 4x and positive 1x. Of course, you don't need the 1. And then plus 2, that's my last term, it comes straight down. So 4x plus 1x would give me 5x. So I just took that middle term, split it into 2 new terms. And then we do factor by grouping. Okay, factor by grouping, you split it into 2 groups. Okay, and the first set of terms, you take out your GCF. So between 2x squared plus 4x, my GCF is 2x. I would be left with an x plus 2. Remember, this is a dividing process. I'm dividing out a 2x. When I multiply it back in, I should go back to the original, 2x squared plus 4x. Okay, here, I don't have a GCF, so I'm just going to take a plus 1 out front, just so that our formatting matches up. Now from here, we've got an x plus 2 in both, so the x plus 2 comes out front. That is our new GCF, is the x plus 2, and what I'm left with is a 2x plus 1. Okay, so we have 2x plus 1 times x plus 2. That would be the trinomial factored. So if I want to factor something like this, okay, well, I'm still looking at the same sort of thing. This is still a quadratic because my largest exponent is 2. Okay, so it's still a quadratic, so my target product, target sum would still work. Target product, target sum. Okay, target product here would be 1 times negative 25, which is negative 25. And then my target sum, I have no x term. Here my target sum was the number next to x. Here I have no x term, so it's 0. So I'm looking for what 2 numbers multiply to negative 25 but add to 0. Okay, negative 5 and positive 5. That would multiply to negative 25, and that would add to 0. Okay, so that's going to be my 2 new numbers when I do split the middle. So here we go, split the middle. We get x plus 5. Sorry, I'm jumping ahead. Give me just a second here. So x squared, okay, plus 5x minus 5x minus 25 would be the split the middle, right? Okay, plus 5x minus 5x. Notice that I included the x in there because if I had a middle term, it would have an x with it. So we have to include an x. So positive 5x, negative 5x. Notice they add together to give me 0. Then factor by grouping. Here I've got a GCF of x, left with x plus 5. Here I've got a GCF of negative 5, which would give me x plus 5. Don't forget, when you take that negative out, you have to change the signs inside. Okay, you have to take the signs inside. If you're still lost on that, go back and look at the factoring by grouping. Okay, that was in the first part of this unit. That would be the very first lesson of this unit. So that will help you there if you're still getting stuck. So here I would get x plus 5 and x minus 5. Okay, x plus 5 is this factored out, and then I'm left with x minus 5. Please note that had I taken the square root of x squared, I'd have gotten x, and the square root of 25 would have given me 5, and I have a plus and a minus. That's going to come in handy here in a little bit. Now here, x squared plus 25, so the same sort of thing. Target product here is positive 25. Target sum is going to be 0. Okay, so I'm looking for 2 numbers that multiply to 25 but add to 0. Well, that's going to be a little different here. Okay, 1 and 25 would give me 25. 5 times 5 would give me 25. Okay, I can do negative 5 and negative 5. That would give me a positive 25. Same thing with negative 1 and negative 25. But I can't get 0 because here I'm going to get 5 plus 5 is 10. Negative 5 minus 5 is negative 10. There's no way to get 0 if both of your signs are the same. The only way to get 0 is if they have opposite signs. So here we're going to call these prime. Okay, so anytime you see the sum of squares, it's going to be prime. The difference of squares we can do. Okay, and it says it really big in this nice little box that's all highlighted for you. Okay, there's a formula. We did this before. Okay, we have already done this part. We took a plus b times a minus b and found it to be a squared minus b squared. Okay, which is what it says here. And we did that, I believe, back in unit 6 or 5 or 6, somewhere around there. Okay, now we're just reversing that. So now if I've got a squared minus b squared, it factors out to a plus b times a minus b. Okay, so square root both of them, you'll have a plus and a minus. Makes it super easy, super quick. Okay, again it says here there's only a difference of squares. We do not have a sum of two squares. Okay, we call those prime. No sum of squares, let's call those prime. So factoring the following binomials. Super quick, super easy. You can continue to do split the middle if you want to, but we're not going to. Here we're going to jump ahead, and we're going to take the square root of both of these. Square root of x squared is just x. Probably need to zoom in a little more, sorry. Just realized that was a little bit small. Okay, the square root of x squared is just x. Square root of 9 is 3. Okay, notice I don't take the negative with it. We don't want any imaginary numbers or anything like that. Okay, square root of x squared is x. Square root of 9 is 3. So when I factor, I get x plus 3, and I get x minus 3. Okay, super easy. Find these two numbers right here, your a and your b essentially, if you're looking back up at the formula. You find your a and your b, you get a plus and a minus. Super quick, super simple. Make sure you take your GCFs out first, just like we do on everything in Unit 2. Take GCF out first. Okay, that'll help you. Some of these things aren't perfect squares. This only works if these things are perfect squares. If they're not, then you have to consider a different method. So for instance on B, they are perfect squares, but I also have a GCF here, 9 and 36. I can take a 9 out front. I get an x squared minus 4. Okay, this is going to prevent me from having to take GCFs out at the end if I go ahead and do it first. So 9 comes out front, I've got x squared minus 4. I'm not done though. X squared minus 4 is the difference of squares. Okay, difference of squares. Anytime I see that difference of squares, I have to factor them. So square root of x squared is x. The square root of 4 is equal to 2. Again, we don't take that negative with it. Okay, the negative is what allows us to actually do these, so you don't have to put it under the radical. So 9 stays out front. I get the x plus 2 and x minus 2. Okay, find those two numbers, square root both of these, you get x and 2, so we get x plus 2, x minus 2. That's it, you get a plus and a minus of each. Okay, C, super quick, super easy. It is the sum. We don't do the sum, so this is automatically prime. Okay, that is the sum of squares. We do not do the sum of squares. Now D, they're going to try to trip you up. They're going to throw in extra exponents. Just keep in mind that extra exponents typically means extra steps. So they are perfect squares. So we'll start there. The square root of x to the 4th is x squared. And the square root of 16y to the 4th is 4y squared. So that'll be our first step. So here we go. We get x squared plus 4y squared and x squared minus 4y squared. Okay? Now there, on the other ones, we were done. Here we've got extra exponents, extra steps. So when we're looking at this, here, I can't factor this anymore because of that plus. Remember, we don't do the sum of squares. They're both squares, that's a sum. It's fine, leave it alone. X squared plus 4y squared. It's going to drop straight down. Now this piece, however, is the difference of perfect squares. X squared is a perfect square. Square root of x squared is x. Okay, and the 4y squared is a perfect square. Square root of 4y squared is 2y. So that becomes my two new numbers. I've got an x and a 2y. So when I factor this, I get x plus 2y and x minus 2y. Okay, and that's this being factored into two pieces. And that would be your final answer. Nothing else I can do. Okay, I'm looking for, do I have GCFs in any of these? I do not. Do I have a square left? I only have a square here, but that's a plus in the middle, so we're done. That would be your final answer. Okay, so that's what you're looking at. So same thing here. I can go ahead, I can take a 9 out first, just makes my life easier. 9a squared minus 1. Okay, factoring out my GCF. Again, if you're having troubles with the GCF, you need to go back to the first section of this unit to learn how to do the GCFs. From here, we're going to go ahead and square root. 9a squared is 3a, and the square root of 1 is just 1, so those are my two new numbers. So when I write it out, this one comes down, I still have a 9 out front, and now I've got a 3a plus 1 and a 3a minus 1. Okay, these things are nice and simple, nice and quick. Just take the square root of both, plus and minus. Square root of both, plus and minus. This has got a plus, don't even have to do anything, just write prime. Okay, if we just remember that we don't do sums of squares, it makes our life much easier. Now, sum or difference of cubes. This, unfortunately, is something you just have to memorize. Okay, we have two formulas here, a cubed plus b cubed. We'd have a plus b times a squared minus. Now this needs to go away. If you're copied, if you printed out notes, there is no 2 in these. A squared minus ab plus b squared, and this is a minus b, a squared plus ab plus b squared. Okay, so if you printed out notes, there is no 2 in there. Okay, so please make sure that you get that crossed out. Okay, so when we look at this thing, let me move that cursor. I don't even know if you guys can see the cursor, but I can see it and it bothers me. Okay, so this is something you just have to memorize. Now, the way that I memorized it, which may help you, it may not, is something called SOMAs. SOMAs. S-O-M-A-S. SOMAs. Okay, SOMAs means you square the first term. Okay, you use the opposite sign. You multiply the two terms together. You add, and then you square again. Okay, square the outside terms. Use the opposite sign. This is minus, so this one's going to be plus. Okay, the first set of parentheses will always share the same sign, and then you just use opposite sign. Multiply the two terms together. Add the square of the second term. Okay, square the outsides, multiply inside, always plus, always the opposite of the original. Okay, we're going to go ahead and skip that step 1, 2, and 3 so I can just get you some examples here. So factor the following. Okay, factor the following. So I have x cubed plus 1, which can be written, those are perfect cubes. Remember, you can always do 1 cubed. Okay, you don't really have to take this step, but I just wanted you to see that 1 is the same thing as 1 cubed, so they are perfect cubes. Okay, so we are going to take the cubed root now, because now we're looking at cubes. Cubed root of x cubed is just x. The cubed root of 1 is just 1. Okay, cubed root of x is x, cubed root of 1 is 1. So this essentially is my a and my b. So if I'm going to plug this straight, if you're just a memorizer, just memorize the formula. This is your a, this is your b, plug those in. Okay, it's just a substitution. So here we go. We're going to have a, okay, the first term plus the second term. Okay, I'm using plus because this was plus, so it's just going to come straight down. The original is plus, this is plus. That's your first set of parentheses, and then SOMAs. Square the first term. Okay, and when I say first, I mean whichever one was listed first. And then when I take the cubed root, that's going to be my first term. So square the first term, opposite sign, this was plus, this is now minus, multiply, add, and square the last term. Square, opposite, multiply, add, square again. Okay, and that's considering when we talk about that, we're talking about these two terms here, x and 1. Square, opposite, multiply, add, and square again, which of course would just then be x plus 1 times x squared minus x plus 1. Don't really need the squares there. Okay, that would be your final answer. You don't have to worry about doing anything else. On B, same sort of idea, only we have to take those GCFs out first, just the same as always. GCF first. Okay, that should be the key to this entire unit. GCF first. Next unit, when we're in 11 and we're solving, GCF still has to come out first. So please keep that in mind. So here we've got a 2. It's going to come out. That leaves me with 64x cubed minus y cubed. Okay, so now I'm going to cube each of these. We don't have to worry about the 2 out front. It's going to stay out front. So the cubed root of 64x cubed is just 4x. And the cubed root of y cubed is just y. Okay, so that's taking the cubed root of each of these. Now plug it into our formula. This time it's a minus. So we've got 2 out front. First term minus the second term. Okay, minus because the original was minus. Square the first term. Opposite sign. Multiply the 2 terms. Add. And square the last term. Okay, now I want to say we don't leave things like this. You need to actually multiply this out, and I wrote it out longhand. I wrote it out longhand just so you can see what was happening. This is 4x squared. That means 4x times 4x. So when you actually multiply that out, you should get 16x squared. So when you're squaring these outside terms, make sure you actually square the number as well, not just the variable. So that would be your final answer there. I know they're ugly, I know they're big, they don't look like answers, but those are actually answers. That's what it looks like factored out. Okay, so same thing with the next one. Okay, they might throw some extra variables in there. Same sort of thing. Okay, there are no GCFs, so let's go ahead and take the cubed root of 27, which is 3, and the cubed root of a cubed b cubed is just ab. Remember, we're dividing. 3 divided by 3 is a, so a comes out. 3 divided by 3, there's a b. B comes out. So I've got 3 and ab. Those are going to be my 2 terms. Okay, plug them into the formula. Same thing as always. Okay, so the first plus the second, plus again because the original is plus, square the first, opposite sign, multiply, 3 times AB, okay, multiply, add, and square the last. A squared, B squared. Okay, SOMAs. Square the 3, opposite sign, multiply the 2, add, and square the last one. So square there. D's kind of the same thing as the solving binomial squares. Okay, when you're talking about extra exponents here, you're talking about a couple extra steps. Not a big deal though. Okay, a to the 6th is 6 is a factor of 3, so we're going to use that cubed root. Okay, it's also a factor of 2, so you could have done the binomial squares first, but you would end up having to do the trinomial or the cubes also. Okay, but we're going to start with the cubes because it makes our life easier. So if there's a factor of 3, use the cubed formula. If it is a factor of 2, use the square formula. Always use the bigger of the 2. Okay, so starting with cubed root of a to the 6th is a squared. Okay, 3 goes into 6 twice. Okay, just a review of those. So cubed root of b to the 6th is also b squared. So that's going to be the 2 numbers that I'm using. Okay, same formula. So a squared minus b squared. Okay, minus because that's what's up front there. And then we square the first term. A squared squared becomes a to the 4th. Okay, power on a power you multiply. So 2 times 2 is 4. Opposite sign. Multiply. A squared, b squared. Add. And square that last term. B squared squared is b to the 4th. Okay, b squared squared is b to the 4th. Now from here, okay, this right here, if you notice, is the difference of squares. Difference of squares. You might want to write that down. Okay, so since it's the difference of squares, we have to factor it also. We can't just leave that. So we're going to square root a squared and square root b squared, which is going to give us a and b. So now it becomes a plus b, a minus b. That's the stuff we just finished doing a minute ago. And then we still have this large thing, a to the fourth, plus a squared b squared, plus b to the fourth, all in a set of parentheses. Okay, they just get uglier sometimes, but that's your answer. A plus b times a minus b times a to the fourth plus a squared b squared plus b to the fourth. Okay, just two more here to do for you, your turns. Okay, please note that we are allowed to do the cubes of addition. Okay, the only ones we can't do are the sum of squares. Okay, if this was a square, we would be done, we'd call it prime, but since it's the sum of cubes, then it doesn't matter. So, cubed root of x cubed is just x. The cubed root of 64 is just 4. Plug it into your formula. Okay, again, a and b. Here we go. X plus 4. Okay, first term plus second term. Square the first term. Opposite sign. Multiply the two terms. Add and square the second term. 4 squared is 16. Square the first, opposite sign, multiply, add, and square again. Somas. Okay, somas. That's a good way to help you remember that. That's all there is to that one. Okay, B, same sort of thing. I would consider looking to see if you have any GCFs first, because there is no cubed root of 24 or of 81, but I do have a common factor of 3 here. Okay, so if I take out a 3, is it just 3? Yes, 3. Then what I have left would be 27m cubed plus 8n cubed. Okay, 27m cubed plus 8n cubed. Now I can cube root both of those. The cube root of 27m cubed is 3m. The cubed root of 8n cubed is 2n. Okay, 3m, that's an m, and 2n. Okay, this is a plus, so here we go. We get the first one plus the second one. Square the first term. Remember to square the number also, 9m squared. Opposite sign. Multiply 3m times 2n makes 6mn. Okay, multiply 3 times 2 is 6mn. Add, and then square that second term, 4n squared. That would be your answer. That would be the end of factoring binomials, so that's got both the squares and the cubes, and that is going to be the end of Unit 10. Okay, so Unit 10, just a quick recap, we did GCS and factoring by grouping in Section 6.1, so if that's still an issue, go back to 6.1. We then did factoring trinomials. That was all the split the middle. That's what we worked on there. So that was 6.2 and 6.4. I believe it's listed as 6.2 and 6.3. And then factoring binomials is actually listed as 6.4. So factoring binomials is what we just did today. Thank you.